Kaiser is a research environment at Halmstad University where for many years we have been using AI and machine learning to analyze data. We collaborate with a lot of world-leading partners in many different industries. One of our partnerships is with Toyota Material Handling.
The forklift industry is really competitive. All the competitors are able to do more or less the same things with the hardware. To be able to compete in the future, we really need to embrace AI and machine learning. We can develop a lot more services that we can offer the customers by using the data that we already have. We try to understand what the truck is doing by listening to the CAN bus signals and translating that into an activity. That could be driving without load, getting a load, driving with load, and leaving a load. For the customer, the benefit is that they would get a much more detailed view on how they are actually using the truck.
It's a complex challenge. We don't really exactly know how we can find the patterns. We have a big variance between different customers, different warehouses, different drivers.
We have tried to specify rules, but then as soon as the driver starts to do something that is just a little bit outside the intended usage, those rules will fail.
Halmstad University is one of the leading universities within a data-driven approach. By engaging Halmstad, we got a boost in that learning curve to move forward faster.
We are collaborating with Toyota Material Handling on a project called activity recognition. We have tried several different techniques, normal deep neural network or DANS, and then in more recent work that we have published, we have been looking at recurrent neural network, which is called GRU, gated recurrent units.
The challenge is in overlapping activities. Sometimes the driver performs two activities in parallel, turning the truck, meanwhile lifting the fork. If we translate this into machine learning language, it will be for some of the data we have one label, but during the overlapping activities we have two labels. That will confuse the model. So applying a machine learning model that can only capture the current moment will not work. We need the recurrence method that can remember the contextual information to help us to understand the current moment. What we end up in is a 3D space that can represent different activities and also different activity transitions. And in that sense, we can draw decision boundary in deciding which data belongs to which activity. The dry whip flow is presented with the yellow custard here, and then the leaf flow is the red one. And you can see all these small triangle dots in between. Those are the transitions. Without AI, we couldn't deliver such a stable, cheap, but also accurate monitoring on forklift usage.
We have been comparing our result with the rule-based techniques, and usually the methods that we are developing, they better capture the transition between the activities in compared with the baselines and rule-based techniques.
Collaborations like this with Halmstad University is very important for us, making it possible to develop new services and new knowledge, I would say.
I believe that a data-driven approach and using machine learning is here to stay. It will be more integrated into our forklifts, it will be running on our forklifts, and it will eventually lower the cost for our customers. We see a lot of opportunities within predictive maintenance where we can mix the activity recognition with data from other systems to be able to forecast when it's time for service, which will allow us to give a better service and decrease costs for the customer. We are close to a point where we will have more compute power on the forklifts, which will enable us to do edge computing. Edge computing means that we can take the research, the models that we developed together with Halmstad, and put that on a forklift.
The AI revolution will really change how we do things, the same way that steam and electricity changed it before. But now, instead of physical power, we are talking about mental power, about ability to understand things we could never understand before. And Kaiser is at the forefront of bringing new scientific findings to our industrial partners for real-world applications. There is no limit to what is possible with AI.